Hi guys, my name is Kyle and I'm here with my buddy Jamal.
Hey.
Today we're going to discuss Module 1 of the Boy Scout Nova Award. Shoot!
Oh!
So let's start with this weird thing called projectile motion.
What is that? So projectile motion is the motion of an object where the only force acting upon it is gravity. And projectiles, well, they're the objects that are in motion.
Wait. Are you saying that throwing a tennis ball or launching a cannonball is projectile motion?
Mm-hmm. Hey, even throwing your cat across the room counts as projectile motion. Just don't try this at home.
So by your definition, is dropping a ball also projectile motion? I mean, the only force acting on it is gravity, right?
Great question. When you drop a ball, the object is traveling along one dimension, and this is called free fall. Whereas in projectile motion, the object is traveling in 2 dimensions.
2 dimensions? I'm confused. What does it mean for the ball to be traveling in the 2nd dimension?
I think you've already figured it out. You notice how you said when you drop a ball, the object is already traveling in 1 dimension, whereas when you throw a ball, the object is traveling in 2 dimensions. Throwing a ball gives it an initial velocity, which allows the object to undergo projectile motion.
Boom
shakalaka.
shakalaka.
I think I'm catching on.
What do you mean?
Wait, so gravity definitely affects the path of an object. But what are some other factors that also affect this path?
Air resistance is a good example of another factor that affects projectile motion. This is what helps skydivers when they land. So when skydivers open their parachute, air resistance acts as a resistive force counteracting the effects of gravity to slow their descent. The same way, in projectile motion, air resistance changes the path of a projectile.
So I think I'm getting a hang of what air resistance is. But what about mass? How does that affect the path of the object?
Great question. Let's see an example. So here I have 2 different objects of different masses. Paper, pen. The pen is heavier than the paper. Let's see what happens.
Oh, the lighter object, the paper, definitely landed much later.
But wait! There's more!
More. What happens if I change the shape of the paper? Will that do anything to affect this path? Alright, let's go.
Whoa, they landed at the same time. By simply changing the shape of one of the objects, you got them to have the same sort of path.
Good observation. The key here is that air resistance acts differently on different shapes. We noticed that the flat paper versus the crumpled paper fell at different times. But the mass of the paper remained the same from one state to another. So to summarize, there are only 2 key factors at work here: gravity and air resistance that affect projectile motion.
Very cool. Got it. So there are 2 forces at play that determine the path's object: gravity and air resistance. But what about changing the initial angle at which I throw the object?
Yeah, that makes a difference. Clearly, when you change the angle, it changes the path of the projectile. Also, if you change the initial velocity of the object,
Well,
it affects the path of the projectile.
so we talked about initial velocity, initial angle, gravity, and also air resistance, all affecting the object's path. But I wonder, what about changing the spin at which I threw the object? Right?
But that's a great observation. Clearly, changing the spin is another way to change the initial force acting on the object. The same way in tennis, when you apply a topspin to a ball, it changes the speed at which the object is progressing, which eventually changes the path of the projectile. So to summarize, we have the initial angle, the initial velocity, the spin, gravity, and air resistance, all that can play a role in affecting the path of a projectile in projectile motion.
That's very cool.